All right, so the third lesson in this chapter is dealing with slope. Slope's a weird concept that's super important. You've probably talked about it in some context before. Different teachers give it different words, but we are going to talk about it as slope. You might have heard it called rate of change in word problems, but we're going to talk about slope. Next class, we're going to talk about more of it dealing with like formulas, but right now I just want you to conceptually understand what slope means. So, slope is how steep a line is, okay? The whole point of math, a big part of math, is being able to communicate what we're dealing with. So if I have two lines, I could talk about the distance, how long they are. We talked about that last class. But you could have two lines that are the exact same length, but look different. So these two lines, let's say they're the same length, they look different. How do we describe them being different? You might say like they're at a different angle. We don't actually talk about that and deal with that right now. Okay? The way that we can kind of describe the angle or how they're slanted is by using slope. It is a number that describes how steep a line is. A big slope, like 10 or 20 or 500, is going to be very, very steep. A negative slope, like negative 10, negative 20, negative 500, is going to go down. These ones are going up. Okay? And then a fraction slope, like 1/2, 1/4, 3/700, okay, is going to be shallower. So like that, or like that, or like that, okay? If it was negative, it would be going down and be fractional, and be shallow. Steep. So let's try and visualize and understand what this means. So if I just look at this graph, okay, let's call this distance, and let's call this time. We talked about distance time graphs. This represents someone's walking away from their house. We talked about steepness being fast, and we can understand this. Speed is related to slope. Speed basically means how much distance do you go in time. So if you go fast, it means you go a lot of distance in not a lot of time, or something to that effect. So let's look at this person. They took 3 minutes, or let's say seconds, okay? So they took 3 seconds to go 6 feet. Okay, that was the distance, that was the time. 6 feet per 3 seconds. Most of you would divide that and turn it into 2 feet per second. Now if I had a different person, we'll draw them right here, okay? They clearly went 2 feet in 3 seconds. So really they went, less than a foot per second, right? You could divide that, you'd be 0.66 feet per second. So looking at these two, which one's faster? Clearly this one, right? The steeper line. This one, which was a fraction, was the shallower line. So that's basically what's happening, is that's what it means to be a steep line, to be faster. We're not always dealing with distance and time. It can be different things, but so that just means that like the rate is faster, whatever it is you're comparing, okay? So let's go over again how to calculate this. It's very similar to what we just did in that example, okay? We tried to figure out these two numbers, okay? We needed to know the up and down, and we needed to know the side to side, because we wanted to know distance per time. The way that generally it's going to work, and the formula we use to remember this, is rise over run. Rise means up and down change. Run means side to side change. It's just like distance over time, except it works in any type of unit. So if I do my rise and my run, let's look. And again, we can use distance formula, can be helpful here, but I'm just going to use the graph. This is 6, and this is 3. So when I make my formula, the rise is going to be 6 divided by 3. That's the slope. The other way you can write that, you can simplify, it just turns into 2. The letter for slope is m, and I don't know why. Okay? So the slope was 2. We did rise over run, it gave it to us. Now, something else we need to look at, if I'm looking at this graph, I picked this point and this point because it basically gave it to me. But you can actually pick any point that is not a decimal. So let's pick this point and this point. So let's put these numbers in, okay? So from in this little triangle, which is the same line, it's just different points, Okay, the rise was 2 and the run was 1. So it's supposed to be rise over run. It was 2 over 1, which is 2. It is the same. No matter which points you pick on the line, you could pick this point and this point, as long as you do it accurately, it will always give you the same slope, which makes sense because the steepness of the line is the same throughout. The only time this wouldn't be true is if it's like a curve, and those don't have slopes. Slopes are for straight lines only. Let's do another example. Let's look at this one. So I'm going to draw my lines. Okay, I'm going to put the numbers. This is 3, and this is 6. So now if I do my rise over run, this could be 6 over 3, gives me 2. Now, there's a problem. The slope of this line was 2. The slope of this line was also 2. They're clearly different numbers, or they're clearly different graphs. So the idea is, when we're going up, the number is positive. Here, the line was going down. From here to here, it's clearly going down, because we read graphs from left to right. So because it was going down, I'm going to call this side -6. Be very careful, because a lot of you will think, well, this is 6 long. That doesn't make sense to have a negative distance. This isn't the distance. This is how much is it changing from the start to the end. It was going down, therefore it is negative. So if I put -6 into here, the answer is -2 for the slope. So that means it's the same steepness as the last one, which makes sense. It's just going in a different direction. Okay, so that gives us the answer. We got a negative slope, which makes sense. You will never ever have a negative x value or a negative run, even if you drew, we'll do the next one. I'll do it here. Okay, it doesn't matter how you draw the graph, like this. This number is always positive, left to right. Any type of graph you draw, x will always be positive, and we think of that because basically x is off in time, and you can't really have a negative change in time. So, let's do some weird examples. These 2 points, we need to do rise over run. Let's put the numbers in. The rise, the change, it changed from here to here, is 7. The run, how sideways it goes, it didn't move at all. That means 0. If you do 7 divided by 0, it gives you an error. This line does not have a slope. No slope. Okay? It is the one exception. A vertical line doesn't have a slope. You don't have to memorize that. You can just try and calculate it, and it will give you the answer of error. Error means no slope. Again, a lot of stuff in this unit you can memorize, but as long as you remember the core fundamentals, you have to memorize rise over run. You can find the answer. This is the other kind of weird one, horizontal line. Let's do rise over run. Okay, so the rise is the up and down. It didn't change at all. So the rise is 0. The run, side to side, this one was 4, so we'll put 4. 0 divided by 4 is 0. That's okay. The slope of this line is 0. Horizontal lines have a slope of 0. That's allowed. This is not allowed, but really when we think about it, when we're dealing with functions, this is never going to be a graph because it's not a function. This is a graph, this is a function, it has a slope, it makes sense. So really our rules, slope works for every functional linear equation. But you still got to know this rule, so you don't mess it up. We'll do a couple more. This one gives you the slope and says it goes through this point, and we have to graph it. So I'm going to start with the point because I know that information. 2, 1, so that's a point right here. That's the x value, that's the y value. Then it gave me the slope of -2. I want to deal with this as a fraction because it's always going to be rise over run. So really, if it's -2, this has to be -2 over 1 because -2 divided by 1 is -2. It's the same. So my rise is -2. That means it's going down by 2. So from here, from my starting point, I'm going to go down 2. I like to draw little bubbles so I can count. And then I'm going to go to the right one. It's always to the right one. Then at that spot, I can draw my next point. Now, I could do it again if I want to find some more points. Down 2, across 1, and then put a point right there. Then you take your sweet ruler, and you draw a line connecting them, and you say, bam, that's it, and you continue the arrows forever because the pattern continues forever. Here, we have the same kind of idea, but we have a fractional slope, which is actually easier. Do not, actually, let's put the 1, 1 first. Do not think, okay, I'm going to go 3/4, like 3/4 of the way up like that. Don't do that, okay? We have rise over run for a reason. We said 3 over 4. So from that point, I'm going to go rise by 3. This is positive, it's going up. 1, 2, 3. Then a run was 4. I'm going right. 1, 2, 3, 4. And I can put a point. If you want to be cool and you want to go backwards, you do all the numbers backwards. Okay, I don't recommend this because a lot of kids will mess it up when they try to do it. They're both going to go backwards. So we're going to go down by 3, and we're going to go left by 4. And we can put the point, and now we can actually see it fit the pattern. We did it right. Oops, sorry. Okay, now we got our line. I'm going to put arrowheads. So, talked about 2 skills. The most important formula we learned is rise over run. That's what slope is. The letter for slope is M for reasons. To do rise over run, you take 2 points, the x and y's, and you figure out what the up and down change and the side to side change is. We're going to be dealing mostly the graphs for this section. We will talk next class about how to do it when it's just 2 points. So if I had a line that goes through these 2 points, how to find the slope of that line. It's not very complicated. It's building on what we already did. So you find the rise and the run. If it's going down, it's negative. You divide it, it gives you the number. If you have to graph it, you start from a point, and then you use rise over run, and you count your blocks and put your next point. That's it.